Hello everyone, welcome to Saurav's classes. This is Tushar Shaw, and in this video we will be reviewing the book Vogel's textbook of qualitative chemical analysis, which is the fifth edition. By obviously the name of this book that we normally use to prefer it for for speaking purposes, that is Vogel's analytical chemistry. Okay, so basically this book is based on the analytical chemistry, which is a huge and extremely huge chunk, basically covering of around 30 to 40% of the total inorganic syllabus that we have in our let us say net gate level or jam level or those kind of stuff. So okay, so as this book covers such a big chunk of any kind of syllabus that we are considering here, this book is like extremely huge, covering all sorts of analytical analysis chemistry that we have in our practical syllabus, or you may say, like, basically an analytical chemistry is nothing but the application of normal chemistry in practical labs. Okay, and that is considered as a single subject as a whole, known as analytical chemistry. And as things are mainly, it is concerned with inorganic substances, so that is why it is kept as a part of inorganic chemistry only. Okay, because now we must not confuse this analytical chemistry with just being inorganic chemistry, because organic spectroscopy is also coming under this analytical chemistry, and physical processes of determination, like you may say potentiometry, conductometry, pH metry. So all those kinds of stuffs also, those are coming under the physical. Those were like basically under the physical chemistry part, but as they are used in analysis of such substances, that is why they are kept also in analytical chemistry as well. Okay, of the total analytical chemistry syllabus, a huge chunk is obviously covering the inorganic syllabus, and that is why this part is kept in under inorganic chemistry only. Okay, so this was all about the introduction of what analytical chemistry is. Now I must one thing that I would like to mention, that this book, that is Vogel's Analytical Chemistry, is basically the Bible of analytical chemistry, which is available out there in India. Okay, so basically, if you want to study analytical chemistry, this book will be the most preferred book that you will be having. Obviously, there are other books as well, but this book covers all sorts of things that are there in your syllabus, or they might not be there in your some syllabus at the university level, but the things that are there on your competitive level syllabuses. Okay, so for that cases, we have this in a this book, which is basically is considered as a Bible. You might be knowing that if you ask any professor or so of any reputed college, they themselves, when they were a student, they had followed this Vogel's earlier editions, so as to like get the grip handy on analytical chemistry as well. Okay, so that is why, as this books is going on for generations, and obviously it is being updated edition after edition. So for that, this book is like quite good for analytical purposes. And if you are studying analytical chemistry, I would recommend that, if other than this, you won't be requiring any other book as such. So what you would like to do is, if you want the PDF, let us discuss, and then we'll be seeing. Okay, so the writers, there are many writers of this book, four writers basically. This is the fifth edition, which is derived. Then we have the writers who are G.H. Jeffrey. He is the former principal lecturer and deputy head of the School of Chemistry. Uh, J. Bassett, former senior lecturer in organic chemistry. J. Mendham, which is the principal lecturer of analytical chemistry, and R.C. Dene, who is the principal lecturer in organic chemistry. Okay, so basically you can see that two inorganic and analytical chemistry persons have written this book, and one organic chemistry scientist has written this book. So basically you can now figure it out that as it is considered as a part of inorganic chemistry, still we cannot be 100% sure that all the stuff that are given in the analytical chemistry part is just belong to the inorganic chemistry only. Okay, now, as this book is of foreign origin, okay, all the writers are foreigner, all the publisher is foreign. Okay, so that is why this book is hardly available in any of the bookstore, local bookstores in Indian markets. So if you want this book as a hard copy, what you can do is order it online from Amazon, Flipkart, or any other normal bookstore that is available. You can search it on Google and find it. Other than that, if you want the soft copy, so for that, I like this book is also available on the internet in the PDF form, but it is like not so extensively available. So if you'll have to find it a lot, like go through many of the Google searches for getting the PDF. And if you want to like do not to hassle that much, what you can do is mail me at this website, at this mail, tusharshaw9420 @gmail.com. So if you mail me that in a mail, you can write it that that you require this book. So I'll be definitely replying back to your mail, and I'll be sending the PDF of this book to you. Okay. So like people who are watching my video, that's also classes like quite a time now. They already know that I normally check out on students and see whether they are doing or not via email only. And I have given my email ID a long time back, and I normally give it on various videos. Okay, so please go and check out my other videos also. That is, I've reviewed a lots of books this month, and so all of them are published now, and they are like gaining a lots of views. So if you want, you may go check those out. All physical chemistry books, all inorganic chemistry books, all of them are reviewed there. Okay. So let us now move on to the main part, that is the contents of this book, Vogel's Analytical Chemistry, because the contents chapter, the contents part is of huge, because almost 18 pages of contents are there. Okay, so we'll be going through them one by one, and we'll be discussing what are the like basic salient features of this book, and what are the basic contents that is available. So that will be helping us to prepare for any kind of competitive or non-competitive exam that we are given on. Okay. So first of all, we have this part A, where part A deals with the fundamentals of quantitative chemical analysis. Okay, quantitative is basically the amount that we are consider of. So first of all is introduction. So what is sampling? You types of analysis, common techniques, instrumental methods. Okay, so this is basically introduction chapter. I will like no details as such is required. Now, the chapter 2 is, involve the fundamental theoretical principles of reaction in solution. Okay, so chemical equilibrium, laws of mass action, factors affecting the chemical reactions in a solution, electrolytic dissolution, activity and activity coefficient, solubility product. So all these kinds of parameters, or you may say concept, that we have learned already in our lower classes, that in our graduation level. Obviously, like you can see that solubility product, law of mass action, chemical equilibrium, these concepts are already very well known to us. Okay, they are just given this part in the beginning of this Vogel's analytical chemistry book, because you can understand that solubility product is a part where from which the concepts of precipitation arises. Okay, and as we are using analytical chemistry, we are doing it in the practical. We require precipitation for certain amount of quantitative analysis. Okay, that is why they have explained each and every part in detail, so that you may correlate with the concepts of like how the precipitation is working, what is the theory behind that. Okay, so then we have this effect of temperature on solubility product, and effect of solvent on solubility of the precipitate, acid base equilibria, strengths of acid bases. Now types of discussion related to the acid base part, that is dissociation of polyprotic acid, common ion effect, hydrogen water ion exponent, hydrolysis of salt, degree of hydrolysis, buffer solution, complex ion complexation. Okay, so these were all the acid base concepts. Then we have this complexation, how complex formation works, stability of complexes. We have this metal ion buffers, complexons, which is basically the specific type of complexes that we are considering. So we'll be going into that. Then we have this stability of EDTA complexes. Then we have the electrode potential, electrolytic concentration cells, the calculation of EMF, oxidation reduction cells. Okay, So yeah, so these were all for the basic chapter. Then we have this common apparatus and basic techniques. Okay, so what are the apparatus that we'll be using? Because basically, like for example, if you are cooking, you as the main ingredients of the cooking are required, the utensils are also required, because without utensil you cannot be cook. You cannot cook, right? So that is why we know that certain machines, certain chemicals, certain all kinds of stuff are required, but the main region where the reaction is happening, those are the apparatus, right? So we need to like go through those also and understand those concepts also. So analytical balance, weight, masses, and care for analytical balance, and errors in weighing. So these are like some like when you are taking in quantitative analysis, weights are very well monitored, because obviously we are talking about quantity. So some amount of some amount of reactant can produce some amount of product. So we need to like monitor that what will be the amount of product, and then we have to predict that what will be the amount of reactant as such. Okay, so for those kinds of concepts, we have to learn the concepts of weights. Then we have glassware. What is the water type of glassware? The temperature standard, graduated flask, pipettes, burettes, weight burette, piston burette, cylinders, and calibration of volumetric apparatus. Okay. Then we have water for laboratory use. We have purified water. We have wash bottles. Okay, purified water is basically DI, which is deionized or distilled water. Okay, and wash bottles is basically normal tap water, which is used for washing the all the apparatus. Okay, then we have the general apparatus. We have glassware, ceramics, metal apparatus, heating apparatus, dissect, desiccators and dry boxes, stirring apparatus, filtration apparatus, weighing bottles. So metal apparatus, you may include tongs. Okay, a metal tong, heating apparatus, a wire gauge, stirring apparatus, a glass rod, a filtration apparatus, a filter paper, and a funnel. Okay, weighing bottles. So round bottom on the weighing bottle, you may say the relative density flask, you already know. Okay, relative density flask. Then we have reagents and standard solution. Now reagents are for specific reaction is fixed. There is no such a change in the reagent. So reagents, purification of those substance, and some basic techniques involving weighing, solution of sample, precipitation, filtration, filter papers. Obviously crucibles with permanent porous plates. We use Bush crucible for gravimetric purposes. Then we had drying and igniting precipitates. Now the next chapter, this part, which is basically very important and my favorite part also. So this part includes error, statistics, and sampling. Okay. So basically, why this is my favorite one, because this involves almost all kinds of numericals and nothing else. You don't be requiring to learn any concepts or anything. All concepts that you have learned in your junior classes, that is from class A, in class 11, 12, the statistics part and all those stuff. Only those concepts are required in this chapter. So you will be learning into that. Okay. So first of all, we have this classification of errors, accuracy, precision, minimization of errors, significant figures, use of calculators. Then we have distribution of random errors, basically standard deviation. Okay, comparison of result, correlation and regression, linear regression, and the value of statistics. Okay, so you can see that all of these concepts are already done in your lower level. So you may just go through it. Then you have the sampling technique, which is how to sample, like when a sample is given to you, how do you analyze that, what are the how do you weight that, how do you use for any take it any for any physical examination like temperature or those kind of stuff. Okay, so that is one chapter. Then we have the separation techniques, and basically this part is the most one of the most biggest parts of analytical chemistry that we have. So separation techniques. So the first part of separation technique is solvent extraction. So solvent extraction includes when you're taking a mixture out of it, you are either precipitating or you're like it is kind of a gravimetric type of thing. So you are either precipitating and then you are just sedimenting the I'm sorry, not sedimenting, just decanting the solvent out of it. So therefore you will be getting a pure product in one form and the precipitates in another. Okay. Some applications of this include like let us say beryllium as a acetyl acetone complex, copper as neocupron complex, lead as a dithione complex, nickel as dimethoxyl glyogram complex. Obviously, because we already know that nickel and the precipitating reagent used for nickel is DMG, which is dimethyl glyoxyl, and the complex which is formed is NiDMG. NiDMG hold to, which is rose red in color. Okay. Then we have this very extremely famous method, that is ion exchange system. Okay. Now basically this ion exchange is normally done in chromatographic setup, but it is done in also other methods also. So firstly we will be studying about chromatography, ion exchange chromatography, or what would be the chelating ion resins, etc. Then we have the experimental techniques using just the resin and not any chromatographic column as such, or you may say the chemical methods such as a determination of ion using concentration of copper to ions in a brine solution using chelating ion exchange resin. Okay. Then we have the column and thin layer chromatography, which is basically one of the most advanced and the most effective ways of using chromatographic films, because this thin layer chromatography provides us with extremely accurate amount of data, though being such a huge having such a huge apparatus. Okay. So we have quantitative analysis, thin layer chromatography, high performance thin layer chromatography, and the recovery of separated substances by illusion techniques. Okay. Then we have gas chromatography, which is basically one of the newest ways of chromatography which has been developed in the past few years. Because up till what do you mean? Basically when you say chromatography, we obviously mean we are saying paper chromatography, or you may say thin layer chromatography, which is kind of similar to paper one. But the one thing that is basically not you may say not so much established is the gas chromatography one, because this is basically used in different types of complex. You like determination of aluminium by gas chromatography analysis of tris acetyl acetenato complex. Okay. And then we have the determination of sucrose as its trimethylsilyl derivative using gas layer chromatography. So we'll be obviously going into the details of this further in this video. So firstly let us finish um, the contents, and then we'll be moving. Okay. So part D then includes the fact that the titrimetry and gravimetry. Obviously, we are just discussing the topics of contents. Why? Because we need to the main target of this book review is to like help you figure out what are the basic concepts that are available in this book, and which parts you can study from this book, so that you can rely on this PDF obviously for preparation of any competitive or non-competitive exams. Okay. So that is why I am just focusing on the contents as such, because contents explain a lot, explain everything basically about what are the basic topics that are given to in this book, and whether you should follow this book or not for that specific topic. Okay. Huh. So let us now dig into the topic of titrimetry and gravimetry. Okay. So first of all, chapter 10 we have titrimetric analysis. So titrimetric analysis basically we know that we in practical chemistry we require two titration. Okay. Yeah, so as I was saying that first of all we have this neutralization titration. Now this neutralization titration is like extremely huge. You can see that all kinds of neutralization are being mentioned over here, so I won't be going through each and every one of them. I just stop my screen, or you can just pause your video. You can see that what kind of titration are given to you. Just like you can say that the acid based neutralization titration, then we have the all kinds of acid like boric acid, ammonium salt, nitrate, phosphates. Okay, then we have this alkali type preparation of alkali. Then we have this standardization of hydroxide. Then we have Na2CO3 content in washing soda. Okay, so all these kinds of neutralization titration are given to you quite properly. Then we have complexometric titration, which is basically the formation of EDTA complexes only in species like calcium, magnesium, zinc, you may say. Then we have strontium, you may say. Okay, so all these complexes form EDTA. All these compounds form EDTA complexes quite easily, and therefore they are used in EDTA titrations by obviously forming the chelates from EDTA. Then we have this masking and demasking contents concept. Then we have this EDTA solutions. Okay. Again, we have determination of individual cations by titration, basically back titration like aluminium, barium, bismuth, copper, calcium, iron. Okay. Then we have the species titration, which involves the analysis of mixture of cations and anions. Okay, mixture of cations basically. Okay, so first of all, we concepts like we have total hardness of water. Then we have calcium and lead in a mixture, calcium, magnesium, zinc in a mixture, and chromium, iron in a mixture. Okay, so all these kinds of mixture you have already done in your practical classes. We have already performed this practical in your on your hands from in the practical classes. So basically, you won't be facing any problem studying these concepts over here. Okay. So then we have this determination of anions, so halides, phosphates, sulfates. Then we have precipitation titrations. So let us say the iron oxide precipitation. I guess iron oxide is there. Um, like it is not mentioned here specifically, but iron hydroxide, ferric hydroxide precipitation, brown precipitate will be formed. Then we have the silver nitrate, chloride precipitation, iodide precipitation, arsenate, cyanide, potassium precipitation using sodium cobaltinitrate solution. Okay. Then we have this oxidation reduction titrations with oxidation with potassium permanganate titration. I'm not going into details of that because obviously oxidation with potassium permanganate and potassium dichromate are very extremely widely used concepts, and potassium permanganate also acts as a self catalyst, like as a self indicator, because obviously it is highly purple in color, and if the like normally after reacting the purple color just seizes off. So if the tinge of purple is remaining in your solution, then your titration is completed. We have just been taught like this in our lower classes. And then we have this potassium dichromate titration. Then we have oxidation with cerium sulfate, cerium 4 plus titration, which involves the determination of copper, molybdate, and nitrate. Okay. Then we have oxidation reduction procedure involving iodine, iodometric titration. This is an extremely huge important part for for both practical purposes and theory purposes, because people normally used to confuse iodometric and iodimetric titrations. Basically both of them are different, and like all the titration involving iodine helps us helps us for precipitating, for separating, or helps us in doing titrations for various kinds of species that are there. Okay, be it any cationic or anionic species, that doesn't matter, but it helps in various species, as you can see. Okay, so that is one of the concept that I mentioned. So then we have oxidation with potassium iodide, which basically does the same job. Okay, KiO3. This acts as a like extremely good oxidizing agent when it comes to species like hydrogen, hydrazine, mercury, and arsenic or antimony. Okay, and we have potassium bromate. This also basically does the same job, but the intensity is very less. Okay. So we have this preparation of potassium bromate, then we have determination of hydroxylamine, phenol. All these preparations, like if you had KBRO3 in your lab, then you probably have this syllable thing in your syllabus, this part in your syllabus, like determination of phenol or hydroxylamine. So and that is why, like if you had that, you may have probably performed this experiment and you already know about that. Okay. Then we have gravimetry, also one of the most important and one of the most basic concepts of analytical chemistry, which is used for like certain methods of analysis. Okay, so first of all, what is colloidal state? Basically, gravimetry is normally the formation of colloids, or you may say heavy masses or particulate masses in the solution, so that the complex that is formed may sediment over there, and then we can calculate, after we can filter it, we can then calculate the gravity, basically the mass of the complex which is formed. Okay, so we have to purify. Co-precipitation is a technique. Then we have washing the precipitate and thermogravimetric method of analysis. Okay, so you can see that these are the amount of anions that help us, that are there for gravimetric, that are used for gravimetric titration. Now I am not going into the details of each and every one of them, and for each and every specific cation there is a, let us say, specific complexing agent, or you may say precipitating agent, which is available. So that is used for precipitating that cation as well. Okay, so let us say this iron we precipitate it as FeOH whole 3. So the precipitating reagent is NH4OH for the iron cation. Let us say for nickel, where is nickel? Nickel. Nickel we use DMG, because the precipitating we use DMG as a precipitating reagent, because nickel forms this NiDMG whole 2 complex, which is like very heavy, and it is obviously, as I told you, it is blood, it is rose red in color. Okay. Potassium we use sodium cobalt nitrate, sodium cobalt nitrate for precipitation. Okay. We use strontium. For strontium we use oxalic acid, oxalate, or you may say oxalic acid. Okay, so for the just like these kind of I just remember a few of them. So if you want to like go through the precipitating reagents of the cation, you can go through all of them, and obviously you will be finding out like not each and everything, each and every part of this is used for for is there in your syllabus, but you can go through it. Okay. Zinc is precipitated as zinc sulfide. Okay. Lead is precipitated as lead acetate, or lead chromate. You may say lead chromate is a better substituent. Huh. Then we have anions. So basically, all these anions are there. You may say that, like for example, just like the cations, we have anions. Let us say phosphate is precipitated as using molybdenum, ammonium molybdate. Okay, NH4, NH4 whole 2 MOO4. So phosphate is precipitated in that way. Sulfate is precipitated using BaCl2. Where is sulfate? Yeah, BaCl2, because BaSO4 is formed. Okay. Then we have fluoride is precipitated from some other reagent. Then we have bromate, and bromide is precipitated by AgCl4, AgCl. I'm sorry, not AgNO3. Okay. So all these kinds of species are there. So like they are used for the precipitate which is formed is then used for gravimetric analysis. Okay. So now up till here we had the chemical analysis. Okay. Basically chemistry was involved in up till that part. Now we have electroanalytical method, which is basically using electricity as a way for analyzing substances. Okay. So then we have spectroscopic analysis, and then we have spectroscopy, and basically then we'll be completing the contents. So electrogravimetry is one of the things which is used which uses suction pumps, or you may say those Booker funnel. Okay, so those can help in like electrogravimetry. Then we have conductometry. um, I'm not going into details of conductometry because we have already explained this in many inorganic books. So, like it is very easy for you, and obviously you can do it. Okay. Then we have coulometry, which is basically the calculation of control. Like coulometry is basically calculation of number of the charge that is passing through one of the species, and that is why it is used for certain analysis techniques. Okay. Then we have potentiometry, which is an extremely big part of electronic methods of analysis. So we have to learn about reference electrodes like the hydrogen electrode, calomel electrode, the indicator electrode, the glass electrode, such as ion selective electrode for basically for what kind of ions we are involving. For that purposes, we have to select certain ion electrodes. Then we have instrumentation measurement of EMF. From there, we can calculate the pH, also the pH of the solution. Potentiometry, as I said, potentiometry can also be used for determination of pH. Then we have potentiometric titration of copper, chromium, manganese. I guess silver was also there because we had done potentiometric titration using silver also. Okay. Then we have voltammetry. Okay, so basically voltammetry is a concept which is derived from the physics, like basic the normal physics. We have voltammetry, they have voltammetry in their curriculum. So obviously if the chemical solutions are involved, so that also brings voltammetry to a part of chemistry also. So that is why it is included in this part. So I would like suggest that you skip the voltammetry part, because basically this part won't be like asked in any competitive non-competitive exams in chemistry. Okay, like I am not explaining for physics. Maybe I explain someday on books on physics or concepts on physics, then I surely will be explaining voltammetry. But this video is about chemistry and chemistry, books of chemistry, and how we can use these books for understanding the concepts of chemistry. So for that purpose, I don't think I will be explaining this part. So if you want, you can just go through the voltammetry part on your own, and you can just read it. Okay. Then we have the spectroscopic analysis. Now this is also one of the most important parts of chemistry that we have. Okay. So the colorimetry and spectroscopy. So for the spectroscopic analysis, we have all these kinds of all these cations, and then we have all the anions that we have. Okay, we will be using Lambert-Beard's law for that purpose for the analysis. And then we have this nephelometric determination based on the nepheloxidic series of the coordination compounds, and from that we'll be doing the analysis. Then we have spectrophotometry, not so much important. Infrared spectroscopy, which is basically also a continuation of the Beer-Lambert's law, and it is used for calculation of certain peaks, and where determination of all kinds of basically infrared spectroscopy is used for organic purposes and less of inorganic purposes. Okay. Now we have this atomic emission spectroscopy and atomic absorption spectroscopy. So this part is also quite extremely important, because from here we learn about how sodium lamps are raised, what are those concepts. Okay, so you need to what is a flame, how a flame works, what is a monochromata, non-flaming techniques, background correlation methods, fluorescence spectroscopy. Okay, all those parts. And I guess after that all no other thing as such is required, because appendixes we'll be going to the appendixes last toward the end of this video. So basically from the contents we learned that almost each and every possible explanation that are there in analytical chemistry, you already saw that for voltammetry concept of physics is also there in analytical chemistry. So basically this book is as I have told you, this book is like a bible for you. Okay, and now prefaces are given, so I won't be explaining the preface obviously. So let us now look at the chapters and see what are the techniques that are given. So let us move on from the introduction. Let us move on to some good chapters, so that it will be easy for us to judge whether this book is good for study or not. Okay, so so you can see that this chapter is basically complexons. Let us move on to some other chapter. Yeah. So titrimetric calculations. So preparation of standard alkali. So let us move it down. Yeah. So metal ion indicators is this part. You can see that just in case for the EDTA complexes, you can see that so much details is given about for this EDTA complex. So some practical consideration also given. So determination of individual cations by using the aluminium back titration or procedure is given. Determination of barium procedure is given. By the bismuth the procedure is given. Okay. For calcium the calculation is also given. Okay, with the procedure, and obviously calcium is more widely used in practical labs than copper iron, because calcium is easily available. So that is why they use like calcium for that purpose. That is they have given so much details on calcium also. Okay. Then we are, as I've already told you many a time, that for nickel direct titrations will be occurring. Here we are talking about let us say the complexometric titration. So instead of DMG, EDTA solution is taken, and in that way we are doing. That let us move on to the next chapter. Huh. So here we are talking about gravimetric calculations. Okay. So you can see for silver we are using silver chloride. For sodium we are using sodium with zinc uranyl acetate. Now zinc uranyl acetate, as I've already told you, is a very expensive reagent. Like just a 10-gram bottle of zinc uranyl acetate probably cost about 20 to 25,000. Okay, just a 10 gram, just a small bit of zinc uranyl acetate cost 10 to 20 to 25 thousands of Indian rupees. Okay. And obviously we had this in our graduation days, the zinc uranyl acetate, and our lab assistant didn't basically let us use it by our own hand, because it was obviously very expensive, obviously. Okay. Then we have strontium, we precipitated it as biphosphate, thorium tin, um, nickel obviously by dimethylglyoxine. I've already told you so many times. Now, one of this book is full of prose, obviously, because where you can see that all the topics are given. Now, one con is there. One or two cons are there that I would like to mention. So, first of all, you can see that all the derivations involving calculations are all there. Concepts are well explained in this book. But one thing that is missing from this book is structures. You can see that this nickel complex. Yeah, so this nickel complex, nickel with dimethylglyoxime, this NiHDMG2, this has basically a huge structure that is coordinated from four sides of the DMG part to the nickel atom. So that from that structure you can determine that it has a square planar complex, and like all the structures are properly explained. So that structure basically is missing in this book. You can see that it is not given anywhere, and palladium start. Basically, this nickel DMG complex is not firstly mentioned over here. It is there in other during a titration part also. If you scroll it upwards, so even if they have the complex drawn over there also, but still it is like it was very conceptual for the writer to draw the complex here also, because the students might be learning from the complex as well. Okay. So that is one of the cons that I mentioned. That is the amount of structure, the amount of drawing, the amount of pictures that are there are very less drawn. You can see that the all for every complexes they have just given the you may say the theory and the data and all kinds of this, which is basically accurate. But if you for analytical chemistry, all you need to do is write. There is no such calculated derivations or no such numericals. Few are there, like the chapter in error analysis, as I told you in the beginning. So other than that, all you have to do is just write according to the procedure, according to the theory that is given. The main thing that was missing is the structures. Okay. So other than that, the second con that I would like to mention is, as this is analytical chemistry, we require to solve a huge amount of questions before we can just it is getting mugged up in our memory, so that we can apply it in our exam. So that is one of the con, that one no questions is explained in this book. Okay, there is no questions basically. This is just a textbook, not a workbook. Not even a single question is there. Yeah, examples are there obviously for certain types of concepts, but other than that, all you gotta do is study from this book, and find your questions elsewhere from, you may say, any examination question, or a question bank, a question book for bank from any other bookstore, if you may want it. So that can be done. So basically, this book is Bible, as I've considered now. Every book won't be perfect obviously, so it is my job to point out the pros and cons, and from where it is from which point of view it will be easy for you to catch up the concepts, and from different kinds of books that I am reviewing. Okay, so this was the second con, that is no questions are there, except for the numerical based questions which is there in the numerical and derivation based question which are there. Okay, like in derivation based we have pH metry, and numerical based we have the error analysis part. Okay, so you can see drawings are there. Basically the structures are there, but not as expected as it is to be. Okay, huh. Moving on to some other chapter, let us see what they have given. So conductometry, we have firstly we have this general considerations, the calculations of specific conductivity, derivations regarding that, and then we have this all kinds of graphs. Okay, so graphs, and then we have the graph explanation of graphs, and after that the chapter is finished. Coulometry, basically coulometry is not so much important. Potentiometric titration using precipitation. Then we have EDDM mercury electrolyte complex. We have the Nernst equation going on over here. Okay. So and then we have the determination of nitrate from the voltammetry, and obviously voltammetry I'm not reviewing anywhere. Then we have the spectroscopic calculation. So what kind of basically spectroscopic calculation involves the complexation of any metal ion with some kind of complex, so that it imparts an extremely good color, or electromagnetic radiation which has a wavelength that can be catched up from the spectrophotometer, so that it can give accurate calculations for that purpose. Okay. Yeah, so this was, I guess, all about the Vogel's book. I guess there is nothing as such to explain, because I have already explained the topics, the silent features, the advantages and the disadvantages. Everything is basically covered up. Now all you gotta do is, for the concept that I have already told you, for the chapter that are there in this book, this is a Bible, and if you want to get your get my expertise in analytical chemistry, this is the first book that you will be considering to. There are other books that are having more complexes, more examples, more questions, but that is a topic for different video, because we need to compare all the books and see what are the pros of this book and what are the cons of that book. Okay, so comparison video is also coming up in a few days. So other than that, this book is extremely good, and if you want to, you can follow it for all your things that you are doing. Okay. So here I would like to end my video. Obviously, let us scroll it down up till the index. I guess instead of index, there are many other things that are also given. Okay. Yeah. So the appendices are given. So you can just go have a look at the appendices, or basically, if you want, you can just email me. I'll be just sending you the PDF, and then you can have a good look at this book. Okay. So thank you guys for this video. I'll see you guys in the next one, and in the next video, we'll be reviewing some other book. Okay. So thank you.